Hi, Sarah. How is the audio at your end now? Is it better? Sarah, can you hear me? I've not seen your line.
So you're back.
Yes, I'm online.
Okay, I will have seen it. I will listen.
Okay, let me get feedback from you. How is it now? It's better now, right? Is it better now? Okay, let's continue our lesson. Yes, Sarah. You say what? No. It's okay. No, I said, is it okay now? Is the audio okay now? All right. Let's continue the class. All right. Good day and welcome to today's class. Today's class is a continuation of our previous classes on primary 4 mathematics. And in today's class, we shall be looking at place value in decimal fractions, which is a continuation of our last week classes on place values and decimal fractions. At the last class, I have introduced to you what fractions are, and we said fraction is said to be a part of a whole. And I gave you so many examples about fractions and the different types of fractions, where I said we have improper fractions, proper fractions, and mixed fractions, which most times we call mixed numbers. And I gave you the reasons why some persons refer to it as mixed numbers and non-mixed fractions. We also went ahead to see how we can convert from proper fractions to decimal fractions. Proper fractions are fractions that are said to have both numerators and denominators being separated by a division line. Example, I gave you example of 1/2 is said to be a proper fraction. We have examples also as 3/4 and so on and so forth. And I told you that 1/2 is referred to as a half. 3/4 is said to be 3/4, where 1/4 is said to be a quarter. So 3 times 1/4 is said to be 3/4. Okay, so in today's class, we shall be looking at place values in decimal fractions. And I told you that decimal fractions is a fraction or a number that have a whole number part and a fractional part. Example is decimal fractions can be written in this form: 0.0000. This is said to be in 4 places of decimal. And I said the digit you find before the decimal place is referred to as the whole number part, while the digit you find after the decimal point is said to be the fractional point, the fractional part. And the dot that separates the whole number part from the fractional part is referred to as the decimal point. Now, in order for us to understand the place values in decimal fractions, we shall use these notations. For t, small letter t, it should stand for tenths, while h will go for hundredths, and th will stand for thousands. Example 1, we have it at 0.217, which is a decimal fraction. If you look at the digit 2, the digit 2 after the decimal point is in the 10th place, means 0.2. So 10th place is referred to as small letter t. The first place value after the decimal point is said to be the 10th place value. We have written it as small t. The second digit after the decimal point is said to be at the 100th place value. And the third digit after the decimal point is said to be as the 1000th place value. After 1000, we have tens of thousands, hundreds of thousands, millions, and so on and so forth. Just like we have in whole numbers, while we're treating whole numbers, we looked at the 100, tens, and unit. Now, for the whole number part, they are being abbreviated or denoted using capital letters, while for the fractional part, we made use of the small letters. And that's why you have the unit. After the unit grows into tens, tens grows into hundreds, 100 grows into thousands, thousands grows into tens of thousands, and so on and so forth. While for the fractional part, you have the tenths. You don't have the unit place value of the fractional part. You have the 10th place value, 100th place value, thousand, tens of thousands, and so on and so forth. So, for this decimal number, 0.217, we said the digit 2 after the decimal point is in the 10th place, mean 0.2. While digit 1 after the decimal point is in the 100th place, means 0.01. While digit 7 is said to be in the 1000th place value, and it is represented as 0.1. 0.001. Now, why do we say they are in those places? And if you look at it, when you sum them up together, it still gives you 0.217. Now, it is said to be in the 10th place value because it is said to be divided by 10. That is, in the first place value, as we did at the last class, it is said to be 1 divided by 10. So it's said to be in the 10th place value, while for the second place value, it's said to be divided by 100. That is why it's said to be the 100th place value. And for the 1000th, it is said to be divided by 1000. So in proper fractions, this is how this can be written. And I think we did so many exercises on them where we're expressing them in the 10th place values, 100th place values, and 1000th place values. Example 2, we are asked to find the total value of 2 in the decimal 6.215. What is the total value of 2? Now, we say the place value of 2 is tenths. That is, it is derived from 1/10. So that the total value is said to be 2 times the place value. So the digit you have there is the total value will be the digit times the place value it occupies. So this is said to be 2 times the tenth, which is said to be what? 2/10. And if you look at it, it's written as 0.2. So I shall give you exercises to solve on what I have explained in order for you to know the place values of each of the digits after the decimal point. Now let's look at the relationship between decimals and fractions. We shall start by expressing decimals as fractions. Now, to express decimals as fractions, we take the following steps. These are the 3 steps you need to take in expressing decimals as fractions. 1, we said you write the fractions in expanded form. 2, you put the fractions under the same denominator. And 3, you add up the fractions. So I'm going to use these 3 steps in order for us to express decimals as fractions. I will show you how to express decimals as fractions, and in turn, how to express fractions back to decimals. Although we have done some of it, but I'm going to do it. So example 1, we are asked to write 0.468 as a fraction. Remember, we said this is occupying the 10th place value, 6 is occupying the 100th place values, and 8 is occupying the 1000th place value. So you can have it to be 0.4 can be said to be equal to 4 times the place value, which is a tenth, which is equals to 4/10, and 0.6 is said to be the second place value, which is the 100th place value, which is 6 times 1/100, and this is equal to 6/100, while this is 0.06, sorry, this is 0.008 is said to be 8 times 1/1000, which is equal to 8/1000. That is step 1. Step 1 says you write the fractions in expanded form. So in expanded form, this can be written as, we have it as 4/10 plus 6/100 plus 8 divided by 1000. Step 2 says you should put the fractions under the same denominator. Now we will make the fractions the denominators of these fractions to be the same. Now, in order for you to make it equal, look at the largest denominator. This is what? 1,000. And this is 10. Now, the difference between 10 and 1,000 is that you have 2 zeros more than that of 10. Okay? So, what I'm going to do is I'm going to add up the balance of zeros in 1,000 to 10 to make it equal, so that, and whatever I do to the numerator, to the denominator, I'll equally do to the numerator, so as to make it equal. In essence, what I'm doing is that I'm multiplying both the numerator and the denominator by 100. And when you do that, this gives us 400 divided by 1,000. I have added 2 zeros to make it up to 1,000, and I've also done same to the numerator. Now, why do we do same to the numerator? So as not to change the sense of the fraction. Because if you simplify this, it will still give you 4 divided by 10, because these 2 zeros will equally cancel out these 2 zeros. Now, to 6 over 100, what do we need to do? We need to multiply both the numerator and denominator by 10. So I'm going to multiply this by 10, which gives me 60 over 100, over 1,000, sorry. And this still remains as 8 over 1,000. So, I have done the second step, which says you should make the denominators to be equal. The first step is to express them. They say write them out in expanded form, which we have done. The second step is to ensure that the denominators are the same, which we have done. And how did we do that? By adding up, by multiplying both the numerators and denominators by a factor that will make 10 to become 1,000. I will say that is 100. So we have to multiply 4 by 100 as well as 10 by 100. And for the second fraction, we have to multiply it by 10. And for the third fraction, we did nothing to it. So the step 3 says add up the fractions. We have put the fractions under the same denominator. Now, add up the fractions. For you to add up this fraction, now, in adding up the fractions, remember what you were told, that if the denominators are the same, you add up the numerators. So the denominator is said to be 1,000. Add up, this now becomes 400 plus 60 plus 8. The essence of we making the denominators equal is so as to add up the numerators. For when the denominators or the fractions are equal, you can then add up the numerators. And this gives us 400 plus 60 plus 8. That will be 468 divided by 1,000. So this is how you can convert decimals to fractions. Decimal numbers to fractions. Now, in essence, in order for us to keep aside these 3 steps, to make your work simpler and faster, all you need to do is this. When you have a fraction, say 0.468, a decimal fraction, and you are asked to express it as a fraction, all you need to do is, where you have the point, have it to be 1, put your 1, and then count the number of decimal, the number of digits you have in the decimal places, and replace them with 0, which is what? 3, right? So this becomes 1, 2, 3. And then pick the digits and write them as the numerator, which is 468. If you look at these two, you discover that they are the same thing. 468 over 1000. So that is the simplest way you can write a number, or you can express a decimal fraction as a decimal number to a decimal fraction, to a proper fraction, sorry. So, Ralph and Sarah, do you understand? Ralph and Sarah, let me hear you. Do you understand? Okay, example 2. Example 2 says you should write 15.36 as a fraction in its lowest term. Now, this is going to be a bit different from what we did in the first example, because we are not just to write it as a fraction, rather we are equally going to reduce it to its lowest term. So this can be said to be 15 plus 3/10, or just like I told you, 36 divided by 100. Then you look for a common factor that can divide both the numerator and denominator without a remainder. You can start with the least factor, which is 2. For the purpose of those of you watching, we are going to start with 2. So 2 can go into 3 one time, remainder 1. And when you bring the next digit to it, it becomes 16. 2 into 16 is 8. So in essence, 2 into 36 gives us 18 times. And 2 into 1 cannot. 2 into 10 is 5. 2 into 0 is 0. So we now have 18/50 as a fraction. I'm trying to simplify the fractional part to its lowest term, because that is what the question requires. So look for also a digit that can still divide. And if the first digit you have used, or the first factor you have used, can equally divide, you go back and divide again. So 2 into 18 is said to be 9. 2 into 5 is 2 remainder 1. 2 into 10 is 5. So we have 9/5. At this point, there is no other factor that can divide 9 and 25. So this is equal to 15 plus 9/25. And this is said to be 15 whole number 9/25. So this is how you express decimal numbers as a fraction. Don't forget to like this video as you watch, while I recommend that you subscribe to my channel if I yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also share the link with your friends and families so that they can also benefit from our evening classes. We shall now take the next subtopic, which is expressing fractions as decimals. Sarah, are you here with me? Let me confirm if Sarah is still online. Are you having an issue? No, you go to live. Go to live. Go to live. Have you seen live? Tap on it. Tap on it. Okay. Okay. Is it continuing from where I am? Okay. We shall now look at expressing fractions as decimals. We have seen how we can express decimals as fractions. Now we shall look at how to express fractions as decimals. Now I said to express fractions as decimals, multiply or divide the numerator and the denominator by the same number to bring the denominator to 10 or hundreds or thousands. That is, it should be multiple of 10. It should be in multiples of 10. Example 1, we are to write each of these fractions as decimals. Writing each of these fractions as decimals. We have 4 divided by 5. How are we going to make 4 divided by 5 a decimal? Now, you should concentrate on the denominator. Ask yourself, what will I multiply? Or what factor, what number will I multiply 5 with or divide 5 by to make it a multiple of 10? So, I know that 2 times 5 is 10. So I'm going to multiply 5 by 10. I'm going to multiply 5 by 2, to make it 10. Now, that 2 I'm going to use in multiplying the denominator. I'll equally multiply the numerator by the same 2. So that this now gives me a new fraction, which is an equivalent fraction. 4 times 2 is 8 divided by 5 times 2 is 10. And this can be said to be 8 times 1 over 10, which is said to have a place value of 10. Okay? So that this now can be said to be 0.8, because this is occupying the 10th place value. B, we have 3 over 4. 3 over 4, as we have it, just like I said, concentrate on the denominator. What will I multiply by 4 to give me a multiple of 10? 4 times 2 will not give me 10. What about 4 times 3? 4 times 3 is 12. 4 times 4 is 16. They are not all multiples of 10. Now, the highest I can go is 4 times 25, or the least I can go is 4 times 25, I beg your pardon. And 4 times 25 is said to be 100. So I'm going to multiply the denominator by 25, as well as the numerator by 25. So that 3 times 25 gives me 75, divided by 4 times 25 is 100. So this is said to be 75 over 100. Another way you can convert this to denominator is by taking the denominator, taking the decimal point, the number of times you have as zeros at the denominator to the left hand side. Meaning, as I have 2 zeros, I'm going to move the decimal point 2 times, so that my answer becomes 0.75. Otherwise, you can say this is equal to 75 times 1 over 100, which is said to be the 100th place value, and this is said to be 0.75, which is the same thing. C, we have 3 whole number 1 over 2. Now, all you need to do is to express this, first of all, as an improper fraction, or split it into 2, which is the whole number part and the fractional part. Then you express the fractional part, express the denominator of the fractional part as a multiple of 10. And what will I multiply by 2 to give me 10? That will be 5. So I'll multiply this by 5 and multiply also the numerator by 5. So that this still gives me 3 plus 5 over 10. And we know that this is the fractional part, while this is the whole number part. This now gives us 3 points. This is said to be the 10th place value, and this is said to be 3.5. While for D, we have 4 over 25. Look for a factor that you can multiply 25 with to get a multiple of 10. And the closest multiple of 10 to 25, other than 10, is said to be 100. So what will I multiply by 25 to give me 100? I will multiply this by 4, as well as multiply the numerator by 4. So that this is said to be 4 times 4 is 16 divided by 100. And this is equal to 0.16. So this is what you will get in how to express fractions as denominators. Now that I have done to you. Otherwise, I would have said, what can we divide 25 by to give us a multiple of 10? But it will be very difficult for you to get that. If you divide it by 5, and you also divide the numerator by 5, so you one ends up going into fractions, making it too complicated for you to simplify. So this is what you get as you simplify your work. So let me know if you have any question. Ralph and Sarah, are you following my classes? Do you understand my explanation? Ralph Ralph and Sarah, I'm not seeing you online. You've gone off again. But don't forget to rewatch the live. So let's go ahead. Now, we have discussed decimal fractions as well as their place values. Let's look at their applications. We shall be looking at the application of decimal fractions to money, weight, capacity, and length. Why do you learn all this? This is because you can apply it in the capital market. And as a beginner, we shall be introducing you into money, weight, capacity, and length. Now, the table below shows the prefixes of the unit commonly used for weight and length. So I have the prefix, I have their meanings, and I have how it is used in weight and length. Now, the first prefix we shall be looking at is the kilo. And the meaning of kilo is said to be 1,000. So when you hear of anything kilo, is 1,000 of that measure. Now, in terms of weight, we refer to it as kilogram, and it is abbreviated as kg. While in length, it is said to be kilometers, and it is written as km. It means 1,000 meters, while this is said to be 1,000 grams in terms of weight. 2, lecto is said to be 100. We normally don't use this or that, while for the prefix deca, it is said to be 10. It's said to be 10. I don't know the prefix of 1, but we also have it as the gram, and in length we have it as the meter. Okay, that's why I said it is kilogram. It is 10 times of the gram, 100 times of the gram, I beg your pardon, and 100 times of the meters. Now, looking at the smaller part of it, we now have all the decimals, the fractional part. We have decile. Okay, decile means 1/10. It is 10 times smaller than the gram. So we have, in terms of length, we have the decimeter. I doubt if they have it in terms of gram. We have the decigram, okay? That should be decigram, okay? And that should be dg. Then we have the centi. It means 1 divided by 100, okay? So we have it in terms of grams, weight. We have the centigram, and we have the centimeter. We also have the milli, which is 1/1,000. We have, in terms of weight, we have the milligram, abbreviated as mg, and we have the millimeters in terms of length. So these are some of the applications of decimal fractions to money, weight, capacity, and length. Now, how do we apply this? Now, from what the table I gave you, what it means is that 1 centimeter is equal to 10 millimeters. How did I get that? If you look at the table, 1 centimeter is said to be, when you divide 1 by 100, and 1 millimeter is when you divide this same 1 by 1,000. So, if you are equating both of them, it therefore means that 1 centimeter is 10 times greater than a millimeter, because it is only when you multiply this by centimeter by, it is only when you multiply millimeter by 10 that it gives you centimeter. Same with meters. We have it that 1 meter is equal to 100 centimeters, because centimeters means 1 divided by 100. So when you multiply it by 100, it gives you back 1 meter. So we say 1 meter is equal to 100 centimeters, and 1 kilometer is said to be 1,000 meters, while 1 kilogram is said to be equal to 100 grams. And we have it, and so on and so forth. We have other ones, milligrams and the rest. For the smaller units, we have 1 centiliter to be equal to 10 milliliters, and 1 milliliter is equal to 1,000 milliliters, and 1 liter is said to be equal to 100 centiliters. We also have 0.01 liters to be equal to 10 milliliter, and 0.1 liter to be equal to 100 milliliter. These are conversion rates you need to understand for easy conversion as the time goes on. Now, also remember that in the Nigerian currency, we have 100 kobo to be equal to 1 naira. In the conversion, 100 kobo is equal to 1 naira. And of late, we started having the currency conversion from naira to dollar, dollar back to naira, and dollar to euros and the rest. As it stands, as out of last week, we heard that a dollar, in dollars, you have dollars. $1 is equivalent to 1,000 cents. So in American dollars, you have the dollar and the cent, of which $1 is equivalent to 1,000 cents. So you have to gather 1,000 cents to make, 100 cents to make a dollar. Same way you have to collect 100 kobo to make a naira. Then also countries have their own conversion from naira to dollar. As we speak, we have, for every $1 is equivalent to 1,000 naira. So you should know how to use this, and it becomes easier for you to fit into the capital market. Also, I said to express money, weight, and length as fractions or decimals, the numerator and denominator must be in the same unit. The numerator and denominator must be in the same unit. For example, example 1, we are asked to express as decimals 10 centimeter divided by 50 centimeters. Okay, just like what I told you, this can be said to be, how do we express as decimals? You multiply the denominator by a factor that will make it to be a multiple of 10. And when you multiply 50 by 2, it gives you 10. So we'll also multiply the numerator by 2 and the denominator by 2. So this is said to be 20 divided by 100. And if you do that, you can also divide this. 10 will cancel. 10 can divide both the numerator and denominator. And then this can be said to be 2/10, right? Which is equal to 0.2. B, you have 1 kobo divided by 1 naira. Now, it is either you convert kobo to naira or you convert naira back to kobo. In this example, I would prefer you convert the bigger one to match with the smaller one, so as to make it easier for you. Now, this is equal to 1 kobo divided by, how many kobo can we get in 1 naira? Remember, we said 1 naira is equivalent to 100 kobo. So this is said to be 1 divided by 100 kobo. And then this is equal to, this is in centimeters. Always remember to write the units. 1 divided by 100 is said to be the 100th place value, which is 0.01 kobo. So this is what you will get as your answer. Example 2 says we should express the following in liters. In liters. This is 10 centiliter. 10 centiliter means that it is 10 divided by 10 times. Centiliter means 1 over 100, as shown in our table, that 1 liter is equal to 100 centiliters. So when you are converting, 10 centiliters means 10 times 1 over 100. And what will that be? This is equal to 0, because this gives us 10 divided by 100. And when you do that, this is said to be 0.1 liters. Because it is, the conversion is 1, if 1 liter is equal to 100 centiliter, then 10 centiliter will be equal to X. So divide this by 10 and divide this by 10, it gives you 0.1. So this is your conversion, and this is B. We have 100 milliliter. 100 times milliliter is 1 over 1,000. Okay, and this is equal to 0. This is 100 divided by 1,000, which is still same thing as 0.1 liters, because this gives you 10. This will cancel this will cancel this, and it's 1 over 10, and this is said to be the 10th place value. Also, we have 10 milliliter. 10 milliliter will be equal to 10 times 1,000. This is equal to 10 divided by 1,000. And if this cancels this, it means 1 over 100, and is written as 0.01 liter. So these are some of the applications of decimal numbers in solving in the capital market. In example 3, we are asked to express 1.5 kilometer as a fraction in the lowest term. What you have to do, remember we said, okay, as a fraction, you have to convert it to meters. Okay, for we have it that 1 meter is equal to 1,000. 1 kilometer is equal to 1,000 meter. So 1.5 kilometer will be equal to 1.5 times 1,000, which is equal to 1,500 meters. Okay, we have to express 1.5 kilometer as a fraction in the lowest term. Okay, sorry. As a fraction, you have it at 1.5 can be written as 1 plus 5 over 10. Okay, and this is equal to 1 plus, what is that factor that can divide 5 and 10 without a remainder? Is 5. 5 into itself is 1, 5 into 10 is 2. So this is 1 plus 1 over 2. Okay, and 1 plus a half is said to be 1 and a half. So this is your answer. Kindly like our videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. Be advised to share the link with your friends and families so that they can also benefit from our live classes. Thank you for being part of this class. I shall be attaching the assignments for you to solve at the comment section of this video. Kindly do it and let me have your answers. Sarah and Raphael, do you have any question for me before I go? Okay, you can drop your questions at the comment section while I'll attend to them in our next class. Thank you and do have a nice day.